We're live. We're live.
We're
Oh,
live. Welcome back,
oh,
everybody. Round
Hello.
3 of the Logos team updates. Today we have Giuliano and Igor with storage and messaging, respectively. We're going to start with Igor today to give an update on Logos messaging, how things are going, and he's got some sweet demos for us. Take it away.
I do got sweet demos, which we'll do in the end. So I will be talking about Logos messaging, but in the bottom of my slide, you can see 2 instructions. Please run them now if you want to participate in the end. You will continue to see these instructions through the presentation, so it will just take some time to download, install, and build, and all of that. So what we'll be talking about today is Logos messaging. Logos messaging consists of 2 parts, mainly. Before it was called Waku. Waku was split into a few teams, one of which is Logos messaging. Logos messaging is delivering 2 products. One is delivery, Logos delivery, and one is Logos chat. Delivery is something that was called NIM Waku before, Logos messaging NIM. Now it's called Logos delivery. And the other one is Logos chat, which is a level on top of Logos delivery. Most of these things were working for quite a long time. So for 2026, I believe our goal is to fit one of the Logos requirements for the mainnet is batteries included. So that's something I want to do for Logos messaging. Batteries should be included. It should be easy to use delivery. It should be easy to build a chat app. That's our goal now. So let's start with Logos delivery. Why is it difficult and why is it complex to use Logos delivery now? Right? Because you have to know a lot of things and you have to know how to use it. Imagine I'm a developer. I want to use Logos delivery. I hear about it. Wow, it's a decentralized network. I want to send some messages and receive some messages in a peer-to-peer way. Cool. What I do? Well, first you need to find some peers, right? You input the ENR from the docs. You use a bunch of protocols to discover your peers. Good. I did it all. Well, it wasn't easy, but surely I can send the message now, right? Well, not quite. You first have to select a protocol to send your message, then select a protocol to receive your message. You have to know the differences between them. You have to know to which pub subtopic to publish to. You also have to know what is a pub subtopic, right? Sure, okay. Now, the developer, I'm a developer. I figured it all out. I'm sending messages, I'm receiving them. You surely guarantee that it will be delivered, right? Oh, why would you think so? You can publish your messages, but sorry, you're limited to 150 kilobytes. We'll give you 0 delivery guarantees, and well, might happen that your node will be DDoSed. Sorry. So we need another layer on top of that, which we call reliability. You want spam protection, you want segmentation, retransmissions, like handle if a node was disconnected, and redundant publishing to many nodes. A lot of things you want to do there. So all of this we want to simplify for an external developer to use it. So that's why we're building 2 layers and 2 APIs on top. One is called Messaging API. The other is called Reliable Channel API. Thanks, Corey, for moving it. So this is what we're building. This is where we're focused now. Of course, there's still maintenance and all of that, but this is our main focus. And of course, we want these APIs to be available in Logos Core. So effectively, this is something roughly how easy we want it to be used, right? You just say, I'm connecting to Logos testnet. I want edge mode. There will be 2 modes, core and edge, which will be basically desktop and mobile. Then I'm ready to send my message. I'm ready to subscribe to content topics. Easy as that. Pub subtopics, peer-to-peer reliability, everything is handled internally. So what's the status on this one? We have messaging API developer preview, let's call it this way. Init, Send, and Health APIs are ready. Subscribe and Receive are in progress right now. I hope in some formats, like a developer preview, will be merged before the Parallel Society Festival. Reliable Channel API is scheduled for next testnet, but for now we have some prerequisites ready. Segmentation library was extracted from status. SDS library is ready to go. Sorry, I will use a lot of acronyms. I know Hanno tried to avoid it. I will do the opposite. I will use all of them, hoping that you just know them. So another track that we're doing is support status. We are integrating SDS into status communities. We've done it. The phase 1 is unwrapping messages. After 2 release cycles, we'll introduce wrapping messages, which will actually start using SDS. And some other tracks, which is like maintenance. We have implemented a NEM FFI library, which is very important for Logos Core integration. It allows you to build NEM bindings, C bindings with NEM and all of that. Also, we're finally switching from Nimble's build system to Nimble. That is coming very soon, let's say March. What is going to happen next? Messaging API is moving to, let's say, general availability mode by next testnet. Subscribe Receive API will be there. Will fully support Edge mode, and will, by general availability, I mean it's tested and dog-fooded. Reliable Channel API will be introduced by testnet 02. We'll have to implement SDSR. We'll have to use RLAN on Logos execution. And the next part is we're going to introduce it into Logos Chat. So Logos Chat is currently using actually the old, it's not even using the messages API. It's still using the low-level kernel API of Logos Delivery, but we'll talk about that. And support status will switch communities fully to use SDS. We want to migrate status to Logos Delivery. We want to migrate status to use Logos Chat. These are 2 very big tasks, but they are there somewhere down the road. So this is roughly how the API of Logos Delivery module looks in Logos Core now. It's very simple. You create a node, you can start it, you can send messages, you can subscribe to messages, subscribe to content topics, and you'll receive messages through signals. It's simple as that. So that is what we call the messaging API. Reliable Channel API will be available later. So now looking at this, back to my developer character who wants to build on Logos, I'm asking, well, surely I can have some secure conversations with my friend now using this Logos Delivery API, right? Well, not quite. And here is where we come back to the idea of Logos Chat. So Logos Chat, the goal of Logos Chat is implement secure decentralized conversations on top of using Logos Delivery as transport. What is done by today? I think the most important part here is architecture. So it was very accurately, carefully developed. It's modular. You can replace encryption or transport or parts of it, introduce conversation types. That's why I put it as the first thing, conversation abstraction here. Ephemeral, end-to-end encrypted, one-to-one chats are ready. I'm saying ephemeral, meaning that, well, you will close the app, you restart it, your history is gone. That's down the road. On the other hand, the whole message history is kind of an extension for developer. You could do it your way. Ephemeral chats are also cool. You can still use them, right? So we have forward secrecy, we have post-compromise security, extended triple Diffie-Hellman, double ratchet. It's there, standard things. We have standard and conversation privacy. We're using content topics, so that's all good. For now, we're using introduction bundles with the identity and some encryption information. We're serving it out of band. This will be solved later. And yes, I've already said about developer extensions. Content types are up to the app that is actually using the Logos chat. So this is kind of an SDK. Next, what is going to happen is group chats using DMLS from AnonComms. Thank you, guys. Conversation and message persistence, two different things. So one is saving secrets for conversations, that it's all the keys for double ratchet, and message persistence is the actual chat history. We want post-quantum encryption, contact discovery is there, and contact discovery is twice here. It's because it's very important, probably. And identity is a very big part of this. It's going to be, so most of what you see on the next part is for testnet 02, especially the group chats. Group chats and identity. So looking at the APIs, this is how it roughly looks. Again, you can init the chats, you can create your introduction bundle, then you out of band somewhere using status. You share this bundle to your friend, and they can create a new chat. You will receive the message, and then it's pretty simple. Send message and get the messages through event response. That's one-to-one chats. You might, there is two modules that we deliver for Logos Core. There is Chat SDK module and Chat SDK UI. Don't confuse with Logos Chat module and Logos Chat UI. These are initial proof of concepts. We will solve that a bit later. So it is a bit of a demo time. I will change my screen now. So for those who was able to build the app, very soon you can help us. Corey, I will share this introduction bundle into the stream chat. If you can please share it in YouTube, that'd be great. And I will share my other screen. There we go. So yeah, sorry, I've opened way too many windows. So this is our Logos chat, Logos Core chat UI application. I'm running Logos Core, running the app in the without the Basecamp, without the Logos app. So it's still using Logos Core. It's currently running two modules, which is Logos Chat SDK module, Chat SDK UI. They are interconnected using each other. So what are we going to do today is have a bit of demo for one-to-one chats. So I'm creating an introduction bundle. I'm copying it to my clipboard. So you have the same in the chat now. I actually think that you might need a few of them. So for each new chat, there should be a new introduction bundle. So this one will only work for the first to use. So I'm using the other instance. I will text hello from all hands. I'm sending this message, and surely it's not received, of course, but we know it's sent. Let me try to restart the app just in case. It was running in the background for a while. Maybe some disconnection happened because we're not using the reliable channel API. Again, use introduction, hello from all the hands. Send. There it is. So the message was received. We can see it. We can surely chat between. So it's using Logos Delivery as transport. The Logos Delivery node is running in the infrastructure now. It's not running locally. So the messages you see are actually running through the internet. I will share a new introduction bundle in the chat right now, just in case somebody still wants to connect. Meanwhile, let's create one more chat from the third instance. Hello, 2. There, so we have a few of the chats, 5, 6, 7. All of the messages are received. That's it. I mean, it's pretty simple. Oh, somebody texted me. Hello from Jazz. Hello, Jazz. Hi, Jazz. Nice chat. Congrats. So that's it for the demo. Thanks, Jazz, for participating. We didn't agree on that in advance. I will go back to my presentation mode. If you give me a second to switch the screen. Okay, not too bad. I thought the demo is going to be worse. So I will quickly show you how the messaging is introduced in Logos Core. So we have 3 modules now. There is Chat UI, which you've just seen. It's using the chat module. It's connected to it. The delivery module is also there. It has its own. It exposes the messaging API. Currently, for testnet 0.1, they are not connected. So delivery is still embedded into the chat module. For testnet 0.2, we will actually go like next step. So chat will use the delivery module, and there will be more modules that we want to use. Maybe not in 0.2, not in 0.3 at some point. There will be many interconnections. We want identity. It might be a module, peer-to-peer module, capability discovery, and of course your fancy Logos app built on top of chat and delivery and using them. It's still there somewhere in the future. Thank you very much. That's all for my update today.
Awesome. Thanks, man. Looking forward to playing around with it more in all hands.
Yep. Thank you. I hope it will actually work fully next time.
Yeah. So I used it on Fedora and it wasn't quite there. I think.
Oh, yes.
That means that Frank gets to fix that problem for us later because he also uses Fedora.
Yes.
Good job, Igor. Great work from the chat team or the messaging team.
Thank you.
Appreciate it.
Thank you.
And up next, we will have Giuliano come on and discuss, not you, KSR. Giuliano, come on, talk about Logos storage. Rock and roll.
All right, so let's talk about Logos storage. So let me get started. So I guess a fair question to ask is, what is Logos storage, right? And I guess the most straightforward answer to this is that it's the storage layer for the Logos stack. But to understand what that actually means in practice, we need to look at where Logos storage is today. There are 2 answers to this, right? And where we want to take it in the future. So today, Logos storage looks like a lot like file sharing, right? It's something that allows you to publish, download, and replicate files over the network. And let's get a feeling for how that works by first looking at the API, right? And I'm going to show you the raw C++ Logos storage module API, which is what we want to refine over time. And then there are, of course, going to be all the other bindings for Logos storage, but that's what we have today. And then, of course, we have lib storage, which exposes other types of bindings, but the C++ one is the main thing. Okay, so let's look at how publishing a file in the network would look like. So this thing sort of, assumes you have this sort of Logos modules object that the liblogos runtime will give you. Actually, you create it, but during module initialization, you get this object. And then, the first thing you need to do is configure and start up your node. And this is sort of straightforward, right? You have this configuration string here, which is basically JSON. There's a list of options. This is your discovery port. This is your listen port. whatever that means, right? And then you initialize your storage module, and then this gives you back a result object, and then you check if that worked or not, right? So the simple synchronous call. And then you need to start your module after you initialize it, which will basically, so the first one sort of places the config in place. This is actually what starts the node. And then again, you call start. This gives you back a result object. You check if it's successful, but this time, this doesn't tell you much about whether the operation went through or not, because this is an asynchronous operation. And then you need to listen on this event or signal to figure out whether this worked or not. And then in this case, you get this queue variant list object. And in the first element, you have a Boolean telling you whether this was successful or not. And then in the second element, if this had an error, this is going to have a string telling you what the error was. And then in this case, if it was not successful, you just panic. But of course, like if you want to like chain these calls somehow, in this case, I'm sort of, let's say I'm building some small utility, command line utility. You need to synchronize this. So you could do this probably using a condition variable or whatever it is that you want to use. I didn't double check this with Arno, by the way, to see if I could use this that way, but I think it would work fine. So, what this does is, okay, once this runs successfully, you just continue, and then you can run your next operation, which in this case is an upload. I don't like the name of this thing. It's called upload URL, but you're actually publishing a file. Upload seems like you're sending it to somebody else, but you're just making it available on the network. Regardless, what this does is, you pass it a URL. So in this case, it's a path to a local file, and then you just call upload URL, and then this publishes it in the network. And then again, you have to wait for an event signal, and this could be successful or not. And in this case, let's say that you're writing this sort of publisher utility that you publish a file, and you just wanted to sort of publish this file and then make it available on the network. Once the publish operation is done, it's going to give you back a string, assuming it was successful. And if it was successful, you're going to get something which is a content ID for this file. And the content ID is nothing but a big string, okay, that identifies your file in the network. And that's what you share with other people for them to download the file. So you send this to your friend, and then your friend can write a download utility. And the way this works is pretty similar to the upload. So, you configure your node, you init it, you start it, you take the CID. In this case, I'm hard coding it here, but you could take it from somewhere else. And then you call download URL, and in this case, you pass a local path. And then what this is going to do is that it's going to fetch the CID, the file that corresponds to that CID is going to download it over the network. And then it's going to write it to a local file. Okay, good. So this is, in a nutshell, the publish download flow for Logo Storage. But okay, now we've seen the API. I'm gonna go through what actually happens in the network when you do these things. So suppose you're some node A and you want to publish a file, right? So you call upload URL with your file, and this is going to create a CID, as I just said, right? Under the covers, however, the node A is actually part of a larger network. It's forming a DHT with the other nodes in the network. And then it's going to publish this file. So the way it does that is that it's going to find a node in the DHT, which is the node that is closest to this CID. And then it's going to add itself as a provider at that node. It's actually going to replicate this over the, I don't know, I think it's 8 closest nodes to this node. But at the end of the day, what you get is, this guy here, which is responsible for this CID and maybe some nodes around it, have this list containing A and telling you, okay, A is responsible for CID 1. Now, if node B wants to download this file, they're going to repeat the same operation. They're going to reach the same subset of nodes. They're going to do a get providers. they're going to learn that A is sharing this file, and then they're going to connect directly to A, and they're going to exchange blocks with A, the blocks of the file, using a protocol that looks like Bitswap, if you know what that is. But basically, you're just downloading a file from A. And then at the same time as B, starts getting blocks from A, it's now able to serve these blocks to other peers. It's actually slowly building a full replica of, CID, the file pointed by CID1 in its own node, right? So it's going to add itself as a provider as well. Now, what's going to happen is that if other peers want to download this file now, they're going to be able to ask for that file to either A or B. And if you have several other peers, they're going to form a mesh, which you'll try to, if you're familiar with Gossip, you try to build a mesh that has similar properties. So it's sort of randomized, and this gives you nice properties like churn resilience and load balancing to some extent. It's been known since BitTorrent, I guess for 20 years, right? So this is pretty proven in some sense. And this is nice because, you try to maintain this graph to some extent close to a K-regular graph. So you never have to serve too many peers at once. So in practice, this scales quite well, while at the same time providing reasonable load balancing in the network. Okay, good. Okay, so this is nice, right? So what are the problems though with this? Of course, so currently you can publish and share files over the network, but this is a sort of and these nodes, they're going to store this data, and they are possibly going to help you share it with other peers, right? And persist it over the network. But this replication model is largely organic. I need to want to download the file, and then I download it, and then I replicate it, and then I share it with other people. But if nobody cares about your file, then it's not going to be replicated, and then if you go away, your file disappears from the network, right? So there's not even an attempt to guarantee persistence in some sense. And also the way this is currently implemented leaks personal identifiable information all over the place. When you're doing a query, people can learn your IP and tie it to the CID query you're trying to query. When you retrieve a file, the guy you're retrieving it from can learn that you're trying to retrieve that file, and they know what your IP is. If you're serving a file, the person that is downloading from you knows that you're doing that, and they can tie your IP to it. So in that sense, it's not very different from other file sharing applications like IPFS and BitTorrent, right? They share the same problem, and so do we. Now, I'm sort of telling you where we are today, but I didn't do much of an update, right? So what have we done over these past months? You look at this and say, okay, what are these guys doing? Why are we still at this point? So I think the thing to keep in mind is that Codex, which is the predecessor to Logo Storage, this was a full-fledged persistent storage solution with a marketplace and not much privacy, right? We were running a sort of kind of an isolated team. We didn't have any specs for the stuff that we were doing. And, the logos requirements were quite different from this. So what we had to do is, I guess what I've been doing is trying to steer this in the right direction. So we refocused. So, the first thing we did is we simplified things. So we stripped our code base down to the minimum requirements. The minimum requirements are file sharing now. So that's what our code base reflects now. We do file sharing. And then we optimize it, because turns out Codex was actually bad at file sharing. It was pretty slow. It didn't support files that were very large. So, more than a few gigabytes, things wouldn't work. And the practical transfer rates were about 5 megabytes per second, even in data center conditions. And then your download swarms could not be bigger than a few dozen peers. So that's like pretty small. And by few dozen, I mean like 2 dozen. It will already, and then it would slow down as you made it larger. So now we've done a rewrite of this thing, which in some ways is simpler protocol. And Chris might be watching us. He's doing tests with very large file sizes. Those are synthetic, of course. He's not storing these things, but he's sharing these files and random files, and he can get to like petabyte file sizes. And transfer rates are about 20 times faster as we had before. This is apparently some limitations within the peer-to-peer, so they could be faster. And we've tested with swarms that are hundreds of peers large. So now we have a much better file sharing implementation, which we're going to release soon. And we've also improved a lot in collaboration. So, we've been doing work on providing API bindings for a while. That's even before the Logos restructuring. We've been trying to, we've been refactoring the status history archival service together with the status team. So you can use Logo storage as an option instead of BitTorrent for their history archival service. And then we've been doing a lot of joint research work with the Anonymous Comms team, both on RLN and privacy preserving protocols. Okay, and then finally I feel like we focused a lot more. We had a very large team. This is 20 people, right? And now we have a much smaller team, which is much more focused. Which I think it's also been kind of painful to restructure, but I think it's been a very good thing. And finally, specs, we had none, now we have a few. Still a long way to go, but quality is improving steadily, as is our spec culture. Okay, so now let's talk about next steps. So by mainnet, we would like to address the limitations in the privacy leaks in the file sharing protocol. We would like to have something where neither publishers nor downloaders can be tied to their actions. And the starting point here is Tribler and Tor. Of course, we're doing this still at research stage to some extent, but I want to give you a flavor of how this could work. So the way Tribler does that is, so recall that before I said, a node that's publishing a file, it just adds itself as a provider, right? So it tells, okay, I'm node A, I'm providing CID1. In Tribler, instead of doing that, what you do is you create a circuit, a Tor-like circuit, and then you have the tip of your circuit is called an entry point. And then instead of publishing yourself as the provider, you publish the entry point as the provider, right? This already sort of hides, first it hides who's publishing because you're using a circuit to publish, and it also hides that you're the one serving it because, now people know your entry point, they don't know you, and your entry point doesn't know who you are as well. So this is already better. And then if you have a node B that wants to download a file, again, they don't do a query directly. They create a circuit and they do a query. This is an exit point in this case. This guy's an exit point, and then it does a query as before. It learns about E. It learns about the entry point, but then it doesn't talk to E directly yet. It creates a rendezvous node. So it creates a circuit towards a rendezvous node. And then it talks to E and say, okay, I want to download the content from A, and you should use my rendezvous point for that. And the reason you have a separate rendezvous point is, first, you don't, then the entry point was sort of the public face of this data set in some sense, right? If this is a public data set, they can be tied to this CID, but they can say, I'm not serving any data for this data set, right? Because they don't. By protocol, they don't. And then you also load balance things a little bit, because if you funneled all the traffic through this guy, then if you have a popular data set, maybe that wouldn't work that well. And then finally, after you say, I want to download this data set, use my rendezvous point, then, it builds a circuit. A builds a circuit towards a rendezvous point, and now they can talk to each other. It's a lot of circuits, right? And Tribler does use this more circuit-based approach. The stuff we've been looking at with Anonymous Comms is more mix-based, and mix are not circuits; they're circuitless, right? So this might end up looking like something different from this, but it's just to give you a flavor of how this could work. So I guess the point here is, like, for the foreseeable future, Logo storage is actually Logos file sharing. And we're going to be doing privacy preserving file sharing. This is the goal for mainnet. But in the longer term, we're going to return to the idea of incentivized durable persistence, which is not organic persistence, right? You're not waiting for people to download stuff from you and replicate it for you. You're actually instructing the network to take the data and replicate it and store it, and then you're incentivizing the providers to do that. And then you do the usual dance of compensating providers and punishing the ones that misbehave. And I'm not going to talk much about this, because although I think we understand how to do this very well, when you throw in the fully anonymous component into the equation, these things get a lot more complicated. So we still have to do a fair amount of research before we figure this out. Okay, now I have demo time. Sorry, this thing is floating here because I was adding this last minute. But those are the links for our code. You can look into the storage module, the storage UI, and this is our main, where the lower level code is. And now we're going to do a demo. So I have Arno here with me. Yeah, that meeting with Daniel is not going to happen. I'm going to call him real quick. I wasn't brave enough to do a public call, a public attempt of demoing this, asking you guys to build the node, because we might run into problems with NAT. But yeah, let's see, Arno. Let's wait for Arno. Okay, there he is. Hello, Arno. Nobody can hear you. Can you share your screen? Hey, yeah, my mic doesn't work here. I can hear you. Share your screen. So I'm going to launch the Logos UI app. And we're going to share a file, assuming this goes well. So yes, good. Good. I'm going to, so this is sort of the setup guide, so you start here, and then it sort of helps you a little bit with the NAT. I'm going to use UPnP because I have it set up in my router. It's going to do a reachability check, which, okay, hopefully works. Good. So now Arno is going to upload a file to his node and share his CID. Go ahead. You can upload and share your CID. So hopefully you can see this. This is Arno. This is me. Arno is in Oman, by the way. I'm in Brazil, so it's a 16-hour flight, so it's pretty far. Okay. Send me the CID. Thank you. Let's hope this works. So this might, I see a bunch of dead peers here, so my fetch might fail, but I hope it eventually works. Yes, that failed. Okay, second time is a charm. Now, okay, I fetched the metadata. Now I can actually download the file. Let's see what Arno has for us. Let me just rename this to Arno. Oops. Okay, good. This is a dancing dog. Very good, Arno. Very good. Now let me share something with you. I'm, of course, going to do something a bit more constructive. And I'm going to share Jared's book with him, of course, because I'm not a person to share pictures of dogs. And now Arno can do his thing there. Where are you? Oh, there you are now. Good. Hopefully that will work. Oh, nice. Immediate. Yes, please download it. Yes, very good. Yes. Okay, good. That was quick. There you have it. Now I have some good content in that laptop of yours. Yeah, thank you. That's what I had for today. And yeah, that's it.
All right. We got file sharing. We got chat. We have message delivery. We also got KSR.
Yeah. Thanks so much for the presentation. It's amazing. Yeah.
Awesome. We got it all. Things are working right in time.
Yep.
I think it stands to like point out, and you kind of alluded to it in your presentation, Giuliano, how much of a refocus and shift it was from where you were to where you are today. And the same can be said from the messaging team and non-coms, and like a lot of the effort that has gone from the inception of like Jared releasing the launch strategy document and where we are today has been refocusing all the projects to funnel everything through Logos Core and building up the kind of process of how Logos Core works so that we have this unified framework. And like that's a tremendous amount of work that I think you all deserve a lot of credit for that isn't necessarily talked about too much.
Yeah, this is, I wanted to mention exactly the same thing. Yes. Also, yeah, thanks a lot.
Stole your thunder. Sorry.
Huh?
Sorry? I mentioned it before you got to it. Sorry, I stole your thunder.
Yeah. So sorry. Like I was just yeah. Thanks a lot. And yeah, special thanks here to Arno who did the Logos Core integration on the Stars side, and Pablo and Zoltan doing a great job, and Patrick as well on the messaging side, and obviously Yuri who's managing the Logos Core side. Yeah, it was very short notice. All of these things. Now we still are hopeful that we get some basic documentation, and this will be part of the remainder of this week, coordinating that. Yeah, but great to see that we are at that stage now. One thing that I wanted to add in regards to Logos Storage, just for future, what it will be used for is for the decentralized package manager. So we will be able to download additional Logos Core modules and apps in a decentralized way via Logos Core, and it will be fully integrated. And yeah, so this is one thing that will happen, and we will not be able to see this improved file sharing protocol yet in this. So in the testnet v01, but then for v02 we'll have it. It's already on the testnet roadmap. I updated the v02 items, and yeah, more updates will be coming this and next week. But looking forward to this. Thanks.
Yeah, and if you didn't see it in the All Hands PS 2026 channel in Discord, the EcoDev team, Frank made a video of all of the efforts from Red Teaming team, EcoDev engineering, kind of what's going on the other side of engineering and ecosystem development. So I recommend you watch that alongside these, and that I think gives us a really good viewpoint of like where we are today, so that as we come together in Lisbon next week, few days, we're all on a reasonably same page on like what everyone's been up to, the status of like how things fit together, what capabilities are, et cetera, so that like conversations there are going to be, I think, much more productive. So everyone who watches these, which should be everyone. So if you know someone on your team who hasn't watched them, make them watch them so your conversations later are more efficient. We're going to have a much better time together, spending time together, because we're all on the same page. So I'm going to keep repeating that because it's very important to me. And yeah, I hope to have the All Hands agenda, at least a work in progress draft of it, and published to everybody by the end of the day. There's a few changes that have been made that I got to shore up, and then I'll publish it somewhere. So you can have an expectation of what that day looks like. But in essence, it's 4 blocks, hour and a half each of conversation, presentation, that go from like what is Logos to how we're going to do it to who we're building for to get ready to go into the community. That's the general stream of what we're doing. The details of which I'll publish later. So I'm not seeing any questions today in the chat, except for Dario saying, "Beautiful job, Arno." He feels more decentralized just looking at it. Yeah, the chat, the storage UI from when I tried it last time, which was like storage initiated, to that is drastic in like what, a week and a half time, 2 weeks time.
Arno works fast. Arno
Yeah.
works.
Yeah.
So I think we're on the same page, guys. I think we're gonna start seeing the fruits of all this labor really I don't know, bear fruit. I hate I said it that way, but thank you, everyone. If there's anything else to say, I'll see you in Lisbon.
Thank you.
Thank you. See you next week.
Take care. Bye. Thank you.